So just a little bit of a introduction. Let's do that. And then basically we can start to do a little bit of a techie presentation. So welcome back on another Ignite. Absolutely pleasure to see faces that I've seen before, or new ones as well, and so on. As you can see, my name is Paula J, and you pronounce it Januszkiewicz. That's very easy, obviously. I come from Poland. But my company, Secure, literally a couple of days ago celebrated 11th anniversary. And we are placed in 4 locations, New York, here in the US, in Dubai, in Switzerland, and in Poland, in Warsaw. That's where HQ is. And just like a little bit of my background. And then let's just jump to the technical side of the presentation. Basically, I've been playing with cybersecurity and been in cybersecurity market for the past 14 years. That has been my totally life. My team is doing that too, and so on. My team is 42 people right now. I don't know how that happened. You know, like in IT, we're bad at business pretty much, or at least most of us, or at least myself. So it just happened. But at the end, I'm also a Microsoft Regional Director. I don't work for Microsoft. And I'm a director. It's kind of funny, though. But that's what I've got. This is like an honorable title. I'm very proud of it. And long story short, I do have also access to the source code of Windows, but that's something that is not like 100%, but it's like 99.99%. So I still need to do a lot of effort to do a little bit of a research in cybersecurity to provide tools like today on the 2 days presentation. Because at the end of this presentation, guys, you will have, of course, all of the tools that I'm presenting today. Our team has written 200 tools, and the reason why I'm saying it is because you get them all. When you get to our blog, you don't need to register. Sharing is caring, so that's basically what our team a little bit does. Now, whenever we are thinking, of course, about the subject, we've got adventures in Underland, forensic techniques against hacker evading the hook. So what this is all about? Basically, the presentation is about all these interesting places that we are able to find while hackers get inside. And my job today is going to be to show you interesting places, interesting situations, interesting scenarios. Yeah? I hope, and this was my goal for that session, it's not like one of these forensic sessions where you learn step by step, okay, what to do and so on. It's very useful, for sure. But there's a couple of places that are interesting, not obvious, worth remembering, worth checking, worth writing. So this is basically the perspective that I would like to share with you today. At the beginning, we're going to start with live scenarios, and then we're going to start with offline access. So we're going to be playing with data in REST, extracting different types of information. And at the end of the presentation, I would like to show you a new feature of our tool, which allows you to extract in a clear text answers to security questions that are helping to reset passwords in Windows. I bet you might find it useful, because if you set them up, they're actually stored as LSA secret, which means that everybody who has access to this computer is able to get access to those. So that's basically the plan for today. Interesting? Okay, very good. Happy to hear. So let's start with a little bit of a story, as always. And the story is actually related with situation with our customer. So that story happened just after Ignite last year. So it's like a 1-year-old story. We still are in the project, by the way, so that's quite interesting too. We've got a customer, and that particular customer sends us an email. I'm getting this email, and they said in this email that it's a bank, by the way. Yeah, so quite sensitive situation. And they say that basically they've lost within the attack. They think they've been attacked. This was basically the verbiage. I read every single word in email was, you too, right? But when you see like, I think we've been attacked, that's something wrong, right? It's like, you think or you know? Yeah, you see symptoms or what is happening, yeah? So, okay, but then they say, and we lost $1.9 million or something like this. Quite a nice sum. And could you guys help us? Yeah, so I'm like, hell yeah, this is cool. Yeah, well, it's not cool, don't get me wrong, but, but I'm excited, right? So, and I'm replying immediately, and I'm saying, okay, so do you want to have a call now or tomorrow? And they're like, no, we can have a call tomorrow. That's disturbing, right? So situation is happening in October 2018. So we are having a call with the customer tomorrow, and we are, okay, what's happening? Tell us. And then they say that they've been attacked in June. Yeah. Like, that's called happiness in this world. So eventually, we're like, okay, so what did you do? Did you do some investigation or anything like this and so on? And then I'm getting on my email in a clear text a report with the investigation that says, and I'm like, okay, no password, nothing, yeah, I'm just reading it. And then basically it says that they've been attacked. There is a process that has been like not digitally signed, that they found suspicious, and it's out there, that executable has been removed, but the process is still there, and that's the end of the investigation. I'm like, did you guys actually read the report? Because it says that there is something left over there, and it's working. And they're like, no, we did not, that's why we are contacting you. We're like, oh, that's awesome, yeah? This is just getting worse, yeah? I don't want to be boring here, but it's just really getting worse. So, long story short, they said, okay, so you guys need to come. We're like, okay, maybe it's better to do it remotely, it's going to be faster. Like, no, but we will need to install remotely monitoring software for you, yeah? And we're like, okay, so hackers can get in, but we cannot, yeah? But they're like, pretty much, yeah? That's the internal procedure. Okay, awesome. So after a couple of days, they are like, would you mind installing monitoring software for us? Because we don't know how to do that. Yeah, we're like, okay, great. So we're going to connect to, like, where's the logic, yeah? Okay, anyway, we figured something. It's December. There was like silence in the project. Yes, they were making a decision. So basically, I'm at the customer side somewhere, and I'm getting an email. Also, like, I'm like, oh, these guys, I'm interested, let's open it up. And then basically, there is a domain admin clear text username and password being sent. And they said, we're sending you the high privilege access, so keep it secret, yeah? Could that go much worse? No, it couldn't. But anyway, my point for that is that there's lots of different types of situations. Of course, sometimes we don't even know that they're happening, where we need to perform investigation. These guys absolutely didn't know how to approach the incident response procedure, but they also didn't know how the threat in the infrastructure looks like. And my goal for today is to show you different situations where hackers can hide a little bit, and our job is going to be to find it, all right? So I'm going to start the presentation with a little bit of a warm-up demo. It's going to be a live scenario where we're going to be hiding a process very quickly, and then we're going to be finding it. Of course, it's like a little bit with kids and having fun at home when someone puts a blanket on themselves. It's like, oh, nobody can see me kind of thing. Of course, everybody can see you. It's the same thing like with hiding process in Windows. So let's have a look. So what we're going to do. First of all, we're going to get into the virtual machine, which I have a debugger connected to. All right? So that's this one here. Now, what I'm going to do, let me just run it. So this is basically here, Task Manager, as you can see, and we've got a Notepad process that we're going to be looking at. Notepad is over here, so we can see it. It's opened, process is there, everything is clear. So what I'm going to do now, I'm going to, by having a debugger connected to the machine, hide that process to simulate a behavior of hiding a process, obviously, but this is exactly how rootkit works. This is exactly how we are able to hide things in Windows. And there is, by the way, only one way of doing it. That's what I want to show you, so that things are not hidden anymore, basically because they are in a memory. So let's have a look. Here I've got a debugger, and I have broken into the machine. So this is basically a control break. And what I will need to do, I will need to play a little bit with, first of all, let me just put it up like this, find the process. Let's just take it like this, because it needs to be in a separate window, so that we are able to hide it. So first, let's find Notepad. And what I'm running over here is the !process command, and then we've got 00 notepad.exe. Why like that? It's a debugger's language, right? So basically I'm saying 0 because I don't know the process ID, and I'm saying second 0 because I would like to have basic information about the process, and then I'm giving the process name, yeah? I have this demo constructed in a way that I don't have to type things. So if you will be interested in downloading these commands, go to our blog, and then you will be able to pretty much get them and do the same thing. So every single process in Windows, and this is important, is basically described by the structure. So in order to be able to display the structure of the process, I will need to copy this particular 64-bit memory address and do .process, and then basically put the process address. Yeah? So this is the situation where I'm actually inside the process. Now, what I'm going to do next is that I'm going to display the eProcess structure, and that particular structure describes us how that process looks in the user mode, so to say. So we've got a K process structure and E process structure. Why do we care about that? Well, basically, that's what the maximum about the process is out there. So if you ever wondered what process can be, what kind of protection methods are there, and so on, that is basically what is described by that structure. And that's it, from beginning to the end. Yeah? Now, that particular E process structure has also inside a list entry structure. And what is important for us is this. We've got two components of that structure, Flink and Blink. I find it a little cute, especially because it's like Blink, kind of. I don't know, what do you think? But eventually, we've got these two things. And then Flink stands for forward link and Blink for backward link. Yeah? So what does it mean? It means that every single process in Windows, and that's important information, is actually described by the list as well. And that list is like you're just grabbing everybody's hands. And like everybody, like let me present it. Yes, so basically, when I'm the Notepad, for example, because we're going to be playing with Notepad, I've got a hand over here and a hand over here. That could be forward link, that could be backward link. Yeah, and the other guy over here, whatever that will be, will point to me. So there's like two hands. Yeah. Now the thing about hiding things in Windows is that if I take one hand of this guy and hand of this guy, and I know where they are because they are pointing to me, and I put them to each other, I'm hidden. That's it. That's simple. And all of the tools are relying on that list because it's fast. So let's have a look what we can do about this, yeah? So we are setting up two variables, Flink and Blink, yeah? Then we need to calculate an offset and set an offset, meaning the distance in between myself, so Notepad, and the other processes. And that offset is like this. Now we can display a name of the previous process and the next process. So let's have a look. That's these two. We've got a WMI, pure VSC, and so on, and we've got a search indexer. So that's pretty nice. And then the next thing that we're going to be doing actually over here, and let me put this up like this, then we're going to be technically changing these hands. So we will get to the modifying list, and then we're going to do for previous guys, Flink pointing to Notepad, I'm going to take this hand and I'm going to pass it to my forward link. So I did that. And my forward, I'm going to take that hand and I'm going to pass it to my Blink. Yeah? So this is the situation. Now, I'm going to click Go here, but I'm going to do it on my side so that you guys can see this Notepad selected in light blue over here actually disappears. And our question is going to be why. Yeah? So here, it's gone. Yeah, you cannot see it. But this Notepad, it's still there. Because we did not we did not terminate the process. We just modified the list. So my point is that things cannot be hidden, really, as long as they work, because everything that works is in the memory, and that's like a big sentence out there. Yeah? So how do we find this guy? That's quite interesting too. So knowing how these things work, we are thinking, hey, if someone wants to hide something, then we will need to modify that list, but someone needs to manage that list too. And someone needs to also manage resources to processes. And that's the client-server runtime subsystem here. Yeah, so CSR, SS, or DXZ. So that guy needs to know, because if I want more memory, indirectly, I'm talking to this guy, and this guy gives me these resources, okay? So let's have a look what we can do. So what we're going to do here, I'm going to take this Process Hacker, whatever that could be, Process Explorer, Process Hacker, it doesn't really matter. And I'm going to go to client-server runtime subsystem. So I've got one guy here, but I think it would be nice to sort them by name. So there are these two guys on the top. So I'm going to go Properties, and then let's go to Handles. And we are here trying to find the handles to processes that these guys has. But why like that? Because this is the guy that manages resources, so it needs to know where these processes are. And I'm looking at this one right now, and I'm not seeing anything interesting here, so I'm going to just pick another one. So it's going to be this one, Properties. One of these two, I mean, it doesn't really matter. It's like a very short search. And then we've got over here something that is called non-existent process. And that's the 1816. This is like this hiding under the blanket fun, right? Like nobody can see me, but the process ID is this, yeah? Okay, cool. So let's have a look what we can do further. And we're going to get into the debugger again. So this is 1816. So let's find out. Maybe this is this one, maybe it's something else, yeah? 1816. And then we're going to do exclamation mark, process. Same thing, 0, but this time and 1816, and then 0, because we know the process ID, I don't know the name, yeah? And then it searches for this particular process, and this is how we find Notepad. Things cannot be hidden. Now, whenever you guys are using, for example, different types of memory analysis tools, like volatility, for example, just to mention, there are two modules for process scanning. One is called PS Scan, another one is called PS List. PS List is shorter. PS List queries this active process link structure, so it will give you some output from the list. But if you really want to know what kind of stuff is running in the operating system, then you will use PS Scan, because that will go to the client server runtime, some system handles, and it will list slowly each processes that are running out there in Windows. But it takes time. That's why we're relying on a list that is not really reliable, yeah, because we are able to modify that. So just a little bit of a warm-up, yeah? Okay, good. So let's go further. So question is, of course, when we've got something hidden in Windows, something is running out there, and that's what we're going to be looking at, how we are able to investigate, like where to start. So this is something that I would like to also present. So this particular machine is infected with malware. Yeah, someone has been there, yeah, or someone is there, I don't know, yeah, well, let's figure it out. So question will be what to do. But I've learned one thing for sure, that in this particular machine, something is communicating over the network. We can start Microsoft Network Monitor, Wireshark, it doesn't really matter here, but the goal is going to be very straightforward to see is that there is actually some type of communication out there. Yeah, so we've got some type of communication. Now, what is interesting for me, and let me stop it, it's this type of communication, because this is basically malware communicating out of this machine. And my machine is 10, 10, 10, 10, and it communicates to 10, 10, 10, 200. I don't rely on internet, so basically this is an internal communication. And it's making some kind of an HTTP request get for some file, whatever that is. Yeah, I don't know yet. But I see something that is very weird, that the process name for this has been identified as system. Don't get me wrong, I personally don't like it, because system is nothing. I mean, it's just like labeled for like, we don't know what's that, it must be system. And it's with a capital S, so it's important. Yes, so let's leave it like this. Yeah. But by the way, of course, process system, it's nothing but NTOS kernel. So does it mean that kernel is really communicating somewhere like, oh, yeah, okay, let's just don't say no over here. But that is not really the truth. So how are we able to strip this information out of the operating system and learn that system indeed isn't system who is actually communicating out there? And answer to that question is very straightforward. ETW, Event Tracing for Windows. Event Tracing for Windows, it's a platform in operating system that allows us to listen to different types of events that are providing information super detailed, super detailed. This is, by the way, what makes Windows fully accountable, so that we are able to learn what's happening. Now, we could be asking ourselves the question, why then we do not gather this information like every day? I want to know, I want to know. Yeah, where is my log having all of that? And answer is, you would suffer. Because if you turn on all of the listeners, as we call them providers in ETW, then you will lose approximately 20% of performance of OS, which is cool. Maybe we can afford that, depends on the situation, but at the end, that's not really something that we would like to have. So let's have a look how we are able, undoubtedly, to check for who is actually communicating over the network. Yeah? So for that reason, I'm going to use a built-in Windows command called logman. And logman, it's quite straightforward. Is it a good tool to use for this? Well, it's okay tool. The output that it produces could be a little bit better. There is a better tool, by the way. It's called Xperf. It's free, and it's also from Microsoft. You are able also to use it. It's amazing. But for that, we're going to use logman, because for that demo, it's going to be more straightforward. And we're going to start session. Let's call it Ignite, for example. And we're going to specify -p provider, Microsoft, Windows, WinSock, AFD. This is the name of the provider. Now you might be wondering, why do I know it by heart or something? Of course, I know all of the providers by heart. It's a couple of, no, just kidding. I don't, yeah, I'll show you the list. The reason why I pick actually Windsock, it's because I'm thinking that if there is someone that is ordering a traffic, and there is someone that picks that order and wraps it up and sends it to the network, it's gonna be Windsock. Yeah, so we need to get into this conclusion first to pick up an appropriate provider. There aren't that many in the certain scopes of them, so that's not that bad. So we've got a Microsoft Windows Windsock AFD minus output, and let's say ignite.etl, event trace logged, minus ETS. This ETS thing, it's quite interesting because normally when you are setting up a trace session like this to learn something, you will need to set up a stop condition. And this is a good practice, by the way. For this session, I will use the ETS switch, which is like a little bit to leave the door open thing, yeah? So that I can stop it anytime. So this is basically the case. Stop condition would be, for example, size of a log, time, event, whatever you set it up. It's good. It could be circular as well. These logs can grow super fast. The biggest log I've been dealing with in my life was for a customer, which was like approximately 10,000 users using the same web application. And it was in chunks, 4 gigabytes per 30 seconds. Yeah. So, but that was a lot of information, yes? It could grow to a bunch of gigs in general. So let's do that. This is a very talkative tool, as you can see. Command completed successfully, and what? Yeah? And if you leave it like this, we're gonna have a problem, yeah? So that's why that stop condition makes sense. So right now we're waiting for a certain type of a communication from the malware computer to happen, yes? And then we're waiting, we may monitor that maybe with the network monitor or something, but when it happens, we do like this, logman, so we can just do arrow up, and then we've got session stop with the parameter ETS as well. So let's do that, stop like this, ignite ETS, that's good. Command completed successfully, also very talkative, yeah? But anyway, okay, so we have created some kind of a log, ignite ETL. Now there is a built-in Windows tool, trace RPT, where we specify ignite ETL. So this is this one. And then basically we will specify the output, ignite txt, like this. We've got this one, very good. That's overridden, very good. And then basically here we are learning that particular communication, yes? So we can do basically open notepad. So let's do notepad, ignite txt, like this. Notepad, what's this? Okay. Let's just do that. Here we go. It takes a while. There's a bunch of events, so you will see that this actually has a structure of events. And over here, you're able to see different types of process IDs. And we are looking for communication, yes, to, for example, as we were discussing before, 10, 10, 10 to 100. And over here, it actually shows us, so we can go a little bit up here. So this one, process ID, is not a good choice. So let's do it 10, 10, 10 to 100. But it was an HTTP GET, so it was on a port 80. So that's better. And here, you're able to identify the communication process ID with this particular process. So this is basically how that works. And we are able on that level to identify what's going on with this particular processes here. Yeah, so we can go in here and then let's see what we got over here. And that's 3228, that's 3228. We've got a TENA SRV, and basically we can verify further what this process is about. We can go to services, that's whatever very important service that I have over here running, yes? So some kind of communication has been identified, yeah? Now, whenever we are looking, of course, about these two scenarios, we learned that even though we had system kind of undercover, we were able to find whatever is happening over there if we use appropriate tool. Yeah? And there is always a good practice for that. For every single research that we do about finding out what's happening, we use at least 2 tools for finding the result. The reason why like that is because we really don't know what author was doing when they were writing the tool. And with the whole respect to the authors, for example, when you use things like, let's say, even Process Hacker will not show you the communication on the ICMP level. Yeah, so the networking layer isn't monitored. Is it possible to send data through the channel, through ICMP? Absolutely. This is how malware can communicate. So when you will fire it up, you're like, oh, there is nothing happening in the network. Well, there is a lot. It's just that the tool is wrong. Yeah? So this is basically what I wanted to show you over here. Okay, so when we move forward to the different types of data extraction techniques that I would like to show you, we can see here that there is like an executable, yeah? Okay, but this is online. Offline, there might be like nothing. And then you get the workstation and someone says, okay, I mean, we think that workstation has been hacked. Could you please verify what's happening, yeah? So what would you do? So we will go, of course, to the most recently used, etc. We will maybe have a look at the Windows indexing service. We will have a look at the USN journal and so on. But these things, guys, can be cheated on. And it's so important to know that. And this is something that I would like to basically show you today. So let's have a look. First of all, let's get through one innocent demo, which is going to be purely related with extracting information from the Windows indexing service. Windows indexing service is very positive because when there is something that is dropped on the drive, Windows indexing service just takes it and then basically it puts it in the cache. There is a database file which is very easy to read, and when it's there, it's going to be in the cache. So over there, you're able to find that something has been there. Yeah. Now, of course, it could be cleaned, yeah? So this is also a very important thing. So indexing can be cleaned, but everything can be cleaned. But let's talk about it in a second. Let's get into some nice conclusions. So first of all, let's have a look at the Windows indexing service. Now, in order to be able to get into the Windows indexing service, yeah, we need to create a copy of the Windows indexing service database file. How do we do that? Well, we can do it, for example, through shadow copy. Why am I doing this like this, not through VSS admin? Because VSS admin could work very nicely on the servers. So you could do VSS admin, create shadow, but on the client, there is no create shadow option. So that's why I'm using this as an ultimate way of performing the shadow copy both for server and for the client, okay? So what we're gonna do over here, we're creating the shadow copy, of course, using the WMI, and then we are performing over here a symbolic link, and it's going to be shadow copy 1, and that's it. Yes, so this is basically the case. Now, why like that? Because shadow copy, because in general, Windows EDB file, which is Windows indexing service, is actually locked for the copying. Yes, so you are not able to touch it. Yeah, we call it a non-share handle. Let me show you this. So we've got over here symbolic link, and then we've got a C shadow copy 1. So basically, if I get over here to the shadow copy 1, then I'm able to get into the path which contains shadow copy. And this is what we're going to get to. So very, very straightforward. Shadow copy itself is in, we go to the program data, like this, and then we go to Microsoft, and then we go to search, and then we go to data, applications, and then we go to Windows, and if we do dir, then basically here you're able to see, this is a live demonstration, of course, the shadow copy file. That's the biggest one, Windows EDB. I have already copied that because it was going to take some time, so I have already a copy prepared, but I would like to show you how to do it step by step. So what we're going to do now? Well, in order to be able to play with the shadow copy, we need to connect to it, with the indexing service, we need to connect to it. And then we've got, for that, the tool, which is called ESC Database View. It's a free tool that you can download from Nearsoft that allows you to have a glimpse into what is in Windows EDB. But don't forget, you are processing a couple of gigs large file, so you need to be a little bit patient, yeah? So we've got a C analysis Windows EDB, so I'm already connected. And here, in the Windows indexing service file, you've got different types of structures. These structures are allowing us to, of course, see what has been put out there in the index. So if we get into this system index GTR-PTH, let me enlarge this. So this is this one. This is, for now, the most readable database, the most readable index that allows us to see what kind of files were out there on the disk. So if there is something that has been there, but you don't know what you are searching for, yeah, so you are searching for something weird, whatever that weird would be, right? It could be malware called Notepad. Then here we won't find the answer, but it could be helping. So here, let's get into the structure. And here, you're able to see that we've got different types of, for example, folder names, in my case. So this is, again, my live Windows EDB out there, a copy of it. And here, we are able to eventually find something that could be interesting for us. Nobody said forensic is nice, yeah? So that structure is quite big. So basically, we will need to go up, down, and so on, and search for something that will be potentially interesting for us. So a little bit of a lightweight demo. Now, whenever we are thinking about some other things, we could be thinking, okay, that did not bring us information. Where should I go next? Maybe I should go, for example, to USN Journal. Yeah, so USN Journal, or in general, NTFS Journal, it's a transactional journal that contains information about what has been put on the drive. Don't forget, that can be cleaned too. But hey, if it's cleaned, then we're going to get event in the event log. But event log can be cleaned too, right? But at least we're going to see that. Yeah? So let's have a look. Is it really something that we can trust, especially from the information perspective, what type of data it can actually provide to us? So what I prepared for you, it's a small drive where our job is going to be to learn how metadata basically works. So that's going to be this. So here, I've got a drive, yeah? And basically, I've got over here a script which I'm going to load into the PowerShell so that we are able to work on it. And then, so we've got our USN, so let me just quickly get into the USN like this. So we've got USN on the drive. Yep. And what we're going to be playing with, it's a metadata of the files. Because sometimes we could be thinking, if we've been attacked, maybe I should dig into the drive and find out what are the latest, whatever, like files from the past 7 days. But that's more than wrong, because metadata, not only it's not part of the signature of the file, but it can be changed like that, just like that. So this is a very important thing to know. So let's have a look what we can do about that. So over here, I've got, well, data folder. And all of these files, as you can see, they are with the 1st of January 2010. And I've got over here some type of data in a 4.txt. And we're going to modify it. So we're going to do something. And we're going to save it. Good. And again, not a big deal, of course, that changes us the data of the file. Yeah? Now, question is there any possibility we are able to, for example, bring that back to the original state? That's the first question. Second, is it possible to list it somewhere? Because I want to know. OK, absolutely. So let's have a look at this one. So in the script, what we're going to play with, it's the metadata of these files. So first, I'm going to do get file hash from the drive to show you that we've got 999 files and the one that stands out. Then we're going to go to verify last write time. And as we can see, it's different. Yeah? So this is basically to prove that there is something to work on. But then, when we're going to list get member that has time in the name about a certain file, there's one disturbing thing. And it's set. Yeah? So if you have a file that is digitally signed, what is important to know is that of course, signature isn't gone if someone plays on the metadata. So that's one thing. But the second, we could also push this file out to whatever 2004. Yeah? So we're going to do that by grabbing information about last write time from one of the items in this folder, and then in PowerShell, for each item in the folder, I'm going to verify if it's different. Yeah? And if it's different, then basically we're going to assign it to what 1.txt is about. So 1st of Jan 2010. Okay? So let's see what we can do about this. Perfect. Okay? And then let's have a look at 4.txt, what it's about, and we can see that it's back to 1st of Jan 2010. Yeah? Okay. So we're like, okay, so where can we see that? Is there a place to verify? And there's a good news and bad news. Actually, both are bad news, but we always say good news and bad news, so let's make one of these sound better than the other. But anyway, so the good news. The good news is that it's in a USN journal. Yeah? The bad news is that if it's not enabled, it's not there. Yeah? So we need to verify if it's enabled. That's one thing. And also the bad news is that that journal can be cleaned. And another bad news, I'm sorry for this, another bad news is that you can override it by having thousands of transactions of writing to the same file. Yeah, so you're going to generate so many different types of entries about changing, overwriting file, whatever, like whatever that would be, right? Creating an event in the event log could be the same because you're actually committing a change to the file, yeah? That will overwrite the journal. And then you will not be able to find that, yeah? Let's have a look how this journal looks like. So this particular journal, of course, for the operating system drive, is going to be huge, yeah? But here, you're able to find, and that's the last information here, 4.txt basic info change. That's the metadata. But then if we go up, you're able to see that there is a data override which confirms my change that I made to the file. Yeah? So this is a good news and bad news, but that's something that we can't ignore. We just need to know its weakness. Yeah? Okay, so we've got this. Now, whenever we are thinking about all this information, maybe there will be a situation that you will find information in a journal and you're like, that's this file, but it has been deleted. Is it possible to recover it? Yeah, is there a free way to recover it? Because you want it now, and like, of course, we can buy software, and that maybe will be great, but you want to do it now. Is there a way to do it quick? Yes, there is. There is a PowerShell module, which is called Power Forensics, which is awesome, and it allows you to recover files. Not only that, but also get information about the drive forensically, but from the file perspective, from the file recovery perspective, it works super smooth, but bad news is that this file, whatever it was, it could be overwritten, right? So the time, it's not really helping here. Yeah, so the quick interesting feature about MFT, so that we are able also to extract data from MFT, and sometimes it can be useful. So let's have a look. So what we got over here, it's, I've got like a VHDX file, and this VHDX has one situation. So basically we're gonna mount it as read-only. I'm doing this as read-only because this is how we're supposed to be analyzing the evidence. Let's do that. And I'm gonna import Power Forensics. So let's just close this, we don't need it. Import Power Forensics module. And our job over here is going to be from that VHDX file to recover a deleted file. Yeah, so this is a typical situation when you've got like a C drive or whatever, and you have deleted the file, and you're like, oh, shoot, yeah, and you want to get back. Yeah, so that could be the method. Or at least to find what type of files are deleted. Yeah, so that's what I'm doing. So get forensic file record, volume name X, and let me just shorten this path a little bit, CLS, where object is deleted. Let's do that. And over here, you are able to see that there is actually one object deleted. It's called p.exe. We've got some metadata, which you should not trust, by the way, because we know that that can be changed. Yeah? But at least there is something. And we've got over here, get forensic file record, volume name X, index 38. Why 38? Because here, that's basically our number of the file. In Linux, we call it inode. Yeah? In Windows, you call it as you want. Some people call it record number. Some people call it index. Some people call it inode. I call it inode, even though it's written over here, record number. So let's see that. And then basically, we're going to get a little bit of attributes about that file. So we can see that there's an allocated size and real size. Where does it come from? Where the difference comes from? Cluster size. Here we go. Yes, exactly, because we're allocating a certain space, but the file does not fill up the whole cluster over here. Yeah, so this is basically what it is. You did not expect that question. It was a bit of a cold call. Sorry about this. Okay, good. So we've got attribute of the file, and then we're going to get into data. So we want to see where this data is placed on the drive. Let's find that out. and not this one, of course, but that one. Okay, and then let's have a look at the data run. What is it? And this is very useful information out there, because we're able to see that we've got a start cluster, yeah, from a certain type of a drive. We've got a cluster length. Okay, so this is 130 clusters, and this is where this file spreads. Awesome. Sparse, false, great. Because if it was sparse, then we will need to treat it a little bit differently. Sparse file is the type of a file which is a little bit lying to us because it says it's big, but for real, it takes a small space. Yeah, not really used in practice, actually, unless there is something specific. Get forensic volume boot record allows us to get information about the drive itself. And here we're learning that we've got a bytes per cluster, 4,096. That's this. So that means that we need to multiply that by 130 times using the offset that we've seen there. Yeah? Okay, so let's do that. Invoke forensic DD, and then we've got infile, offset, block size. So this is basically the offset that we got. Block size 130, as we learned before. Count 1, outfile, C analysis test.exe. And this particular test.exe, it's going to be the file that, let me just get to the folder, that we're going to be playing with. Yeah? So let's see what this particularly is. So test.exe, bang, okay, and let's see on the command prompt what test.exe would be. And let's get into analysis, test.exe, enter, and it opened on my side. That's something that in Europe we call putty, but you guys in the US call it putty, yeah? So how would we call it? Oh, putty, okay, so that's putty. So here we go, but putty is actually digitally signed. But if I go to the properties of putty, then we can see over here no digital signature. So how can I get it? Now here's the lesson that executables are very forgiving. If you add empty space to them, or if you add malware to them, that's another thing. If you add whatever to them, they will still run because there is a certain mark when there's an end, and basically that's what's going to execute, but the other part's going to just be there. So this is how, by the way, you can also hide files. Yeah, and here we have hidden empty space, so to say. So let's have a look. How can we actually get this digital signature out? So we learned over here that there is this allocated size and the real size. Yeah, we can see the difference that there is 80 at the end, 68. So what we're going to do, we're going to take test.exe into the byte array, and we're going to chop it to the real size. And then we're going to save it into the test2.exe. And now I have here test2.exe, it's also putty, but this time it has a digital signature on. That's this, basically, as you can see, C analysis test2.exe. So this is how you can get more information about what kind of files are there. Now, funky part is that, is it possible, for example, for some reason, to get information from the MFT? Because MFT has a funny characteristic that, just because of the efficiency, Windows also puts data into MFT. It's a very small chunk because it's a approximately 700 bytes, but you can still get something out of the MFT. So if there was a small file, then it would land in MFT. Maybe it's going to be a useful file for you. Who knows? Yeah. So let's have a look how we can do that. So in order to be able to play with the MFT, and that's going to be our last thing, I'm going to take this read-only out. I'm going to mount this drive once again. Yep. Fantastic, it's going to be our X drive over here, and I have it. And what I'm going to do, I'm going to create over here a certain amount of files on that drive. Yeah, so I did that. So let me show you how it looks like. Yeah, so there's like wipe me, whatever files. Now I'm going to take these guys, and with Shift Delete, I'm going to permanently delete them, but they're small. Yeah, so we are deleting them. Now, just to be cruel, we're going to also override it with cipher. Why not? Yeah? But the reality is that we are overriding a drive, not the MFT, with the cipher. So let's have a look about the drive itself. Get forensic file record, volume 0, index 0, of course. Here, we've got MFT. Yeah? And from the MFT, index 0, we know what index is because we already explained that, so that's this record number. We will copy the file, whatever it's out there, we will copy file, and we're going to save it as XMFT. And within the XMFT, we will learn that there is something out there, maybe, hopefully, that will provide us some information. So let's just do that once again. Here we go, XMFT. I'm going to open it up. That's this. Very nice thing to read for sure. But eventually, that's basically how it looks like. So it's quite a large file. Yeah? Can we search for something? And answer is yes. Yeah, here, we're able to see some kind of a data. And then, let me just do that. You can see also the file names. So there was like wipe me. Yeah? And these particular files inside, they had actually, inside it themselves, they had our team's name, so secure basically. This was the content. I put it like this so that it's easier for me to see where am I in the file, yeah? So small files are actually out there. So is it really that we are able to hide things? Answer is yes, we are, but we need to be really good at that. And the positive comment about this presentation, that basically every single time we are performing forensics, there's always something that you can find. Question is it useful for you? Because it might not be providing us a good evidence and so on, but at least it will give us some indication that, hey, this machine has been hacked. We have to look further. And this is basically my conclusion for today's presentation. Let's have a look at the summary. Let's make sure, of course, that we've got a good incident response procedure. Because when the time flies, we lose. The quicker we do the memory dump, the quicker we do the disk dump in this order, we are able to find more information about what happened. Yeah, so this is the very obvious one thing. We need to know the scope. Today, this is the first session out of the 3 sessions that I've got. In the last session of the day, we're going to be going even deeper in forensics. If this is interesting for you, come over. We're going to have a look at different types of files as well, and different types of file structures where we're able to extract information to find that hacker actually has been there. So let's know the possibility. Yeah? So that's one thing. And at the end, of course, we need to have a well-written, as we mentioned, the incident response procedure that is tested, so that we know how to act in stress. Because when we are under attack, and lots of our customers were, and I'm sure you've seen that too, they don't know what to do. Yeah? One of our customers actually installed, my heart was bleeding, sincerely. They've installed the evidence gathering software on the server that they were gathering the evidence from. Yeah? And they were like, are we doing a good job? No. Yeah. So this is basically the case. Anyway, of course, if you guys are interested in quiz, have a look. Our team shares it. There is no registration. During the coffee break, learn more about cybersecurity. And to get slides and tools, visit our blog, secureacademy.com. Over there is a special post for Ignite with the tools that I'm using, talking about, and so on. So hopefully you will enjoy them. And at the end, I hope, of course, to see you at the next session that I'm delivering also in this wing of the building. So yeah, hopefully see you there. We're going to be talking about malware. It's going to be deep dive into a little bit of code, but from the IT pro perspective. Thank you so much for coming.